I don't think there's a button that will like help me go for part shrinkage or like other than maybe something in the software. I know there is like scale factors I do, and so like I definitely fine tune a lot of scale factors definitely, but there's not like, that's not in the CAD software portion. That's like in, I'll like open up like 3D Manage and then go in here and then where is it? Where are my scale factors? Somewhere in here. There's somewhere in some of these settings are scale factors, and I can go back in and change, actually I know where some are. 3D Sprint. Engineering builds, let's open that one. I know there are definitely a lot of scale factors, and we'll use delta maps to fine tune those scale factors. And so we'll like, or a lot of times maybe we just print a square. Like it's hard to, all of our delta mapping comes in for like printing organic shapes because you can't measure a tooth, for instance. It's very difficult at least. And so we will, I wonder if I can even log on. But a lot of times we'll like say print a block out, just a hollow block, a very close facsimile of what we're wanting to do. So sometimes if we're printing a, man, none of my passwords are working today. Oh well, if I bring up a printer, say our new 2500, under the more printer tools, printer settings, I've got my scale factors here. If I want to change them, to make a new one, change this to like 104 or whatever, and then print out the part again and then test it. That's how we've normally dealt with shrinkage. There's other issues, there's other like ways to deal with shrinkage of like, maybe you change the layer hatch spacing, or maybe you change the build parameters, and that's into the sort of process engineering portion of these things where you'll go in here and you'll like, in this case I don't have a lot of buttons here, but sometimes I'll like, this list right there will be like 30 parameters long, and I'll go through and change just one or two of them, but like selectively change a couple and be like, these are the ones that really help with scale factors, or these are the ones that really help with shrinkage. Sometimes like maybe turning off every other layer might help with shrinkage, or like maybe turning on all the layers like in printing, because sometimes like the infills don't scan on every layer, sometimes they scan every other layer, or subtle little changes like that can have a big impact on the overall like shrinkage of parts. But a lot of that is sadly trial and error currently. I don't think we have a simulation software that simulates the shrinkage of parts accurately enough. Not that I know of. It might exist, I just don't know of it. Yeah, so there's part orientation helps a lot with surface roughness. So for instance, like if I was to print a tube, and now this might be limited by the machine size, but like for instance, if I was to print just a tube, straight up, that'd probably give me the best surface finish, where like if I print it on the side, I'd get layer lines on the top and the bottom. And so that helps a lot. Some other ones I've seen are, I'm trying to think of some examples. I've seen more for like MJP, where like, for instance, for like an MJP machine, when they have this support material on the part, there's different settings you can do. So like, I think the default setting, it supports it like you would logically think. It just supports all the down-facing surfaces, all like just extrusion down to the ground. But where that wax touches the part creates a funny surface texture. And so in order to normalize that surface texture, we just wrap the whole part in wax. So it'll print like a 1 micron, not 1 micron, like 10 micron layer around the entire part. It's just a different setting. Instead of like HDP, it's HDX, or some setting, it's a button in here somewhere, wherever it is. But you can quickly just change that. Actually, it is, but yeah, you can totally change those settings to get different surface quality issues. For like metals, slightly different in that I don't know, it's not like you just don't want your supports to touch it, basically, if at all costs. If you want a really nice smooth surface that you don't want to machine, don't have supports touch it. That's the only way to really do it, because the supports are literally welded to the part. And so that is definitely an issue. But here we go, print mode. In this one there's just HD, but a lot of times choosing the right print mode determines a lot of the surface quality finishes. And it's a lot like, people don't normally ever click on those buttons or even know that those buttons exist, but like there's definitely a lot of machines have different settings for like, it maybe takes twice as long, but your surface quality goes up like through the roof, or maybe it's don't print any, like for instance, don't print any supports on it. And I designed a part so that it's like supportless printing. And so I've done a lot of things where like it took, not forever, but like it took a little bit longer up front to design a part that prints without supports so I can avoid having to sand things off and avoid having to refine areas. Versus like if I just throw a part in the machine and click print, I might get it right away, and it might be really easy for my designers to just do that, but the overall outcome is like, now I've got to pay someone to sit there and sand out the inside of this part, or like machine out the inside, and what if it's got a bend in it? Or like what if it's a U shape, or like something that's complex, which you can't machine out. And so, but I mean, one of my favorite sort of surface finish is actually machining. It was a combination of printing and machining. So like you'll print basically almost the entire part with a little bit of stock around that edge, and then go and machine off that stock very quickly, like one pass. And then you can get that tolerance back down to something perfect and a nice, beautiful machined finish versus the sort of layering of like a metal print, for instance. Like it's still, ours are fantastic, but it's not a machined, like perfectly glassy, smooth finish. But it's easier to normalize the surface quality than it is to like very specifically change it in one area. It's a good question though. Would like to do more experimenting with that. That's very true. So that would be another one of like, depends on your manufacturing guys at that point. That might be the weak link in the chain, is that like maybe who's ever doing the manufacturing might not be skilled enough to actually figure that out, or maybe they do, they just don't know, or maybe they're just not trained. A lot of times I'll get parts where like, I'll be like, can I please put this thing on there or poke a hole in here, because it'll like make the overall experience way better. But I'm just not allowed to, because like maybe you're not really strict, but like maybe like I shouldn't just go and willy-nilly change your file. And like maybe you wanted me to though, like if we talked one-on-one, or like you would talk to the person who was doing the actual like setting up of that file, they might be like, yeah, totally, we'll just orient it differently. But a lot of times those people aren't really paid to, I don't want to say paid to think, but they're basically just pushing stuff through really quickly, and so they're not like, what would be the best orientation for this part? And so sometimes I'll send them parts pre-supported and be like, print everything. I'll send you the supports and everything, just print it all, and that's exactly what I want. I've got a lot of parts that are done set up that like if I of course, let's see if I can log on. That's why my password wasn't working. Caps lock was on. Or not. Can't log on to anything today. But definitely let me open a supported file. We definitely have a lot of parts that come with supports automatically already on it. So if I go down to Patrick Dunn, Meta Mason, if I grab, no, not that. None of these have supports. That has supports. I send a lot of files to people like this where like I'll basically just do everything in advance. Nope. Nope. Come on, get back over here. I cannot. So there's my support. This is my part with supports. I apologize for it being pushed over to that side of the screen so bad. Close. No. But I mean, that's definitely one of the, what was the question again? I'm sorry. Machining tabs. Yeah, that is definitely a, we've had some, I remember sending off a metal part. It was just a plumbing fixture. And when I just sent it to a facility to have it printed, they were like, we can't print this. Like, we're going to print it solid. Like, can you please send us a solid file and we'll machine out the insides? And I was like, that's weird. You're a printing facility. You should be able to print this part. And I like just flipped it over for them, and it printed just fine when you flipped it over. But they just didn't even, it's not their job to flip it over or to even think like that, and they may not even want to risk, like what if I as a service person modified your part and somehow caused some issue or something like that. Like a lot of times they don't even want to risk doing that. And so that's definitely, it depends on who you're working with. Working with competent people is definitely a plus. And so like this is, the yellow is the supports, for instance, and the gray is the regular MetaMason part. But like this is how I send it off to them, and I'm like, print exactly this file over and over and over again. Or like if that's, some of the things we do are not custom it's not custom manufacturing or like mass custom manufacturing, it's custom complex manufacturing. And so like they just produce the same part all day long. That's just all they do. They just can't make it any other way. And so we'll send them everything perfectly fine-tuned with their machine settings and everything. And I'm like, just click go 10,000 times in a row. And it should work fine. But to get to that point where it was like that one part is perfect and oriented correctly and supported correctly and they get the optimal, or I guess the desired result, probably took 30 or 40 tries or some number of tries beforehand to figure out what exactly was the best thing. And sometimes it's worth it up front to be like, all right, I'm gonna have to print this 5 or 6 times and break it. I break a lot of parts immediately. Like pull it out of the machine, break it instantly. And I'm like, all right, well now I don't have a part anymore to like show the client, but at least I knew where it broke and how to fix it for the next time. And so that's one of our techniques.